In this video, we are going to look at how to solve logs and exponentials. Before we start solving logs and exponentials, we need to talk about a very important property of logs, which is change of base. So on your calculator, the log button assumes that you are in base 10, and we need something to convert other bases into base 10. So change of base says that log base b of x is equal to the log of x divided by the log of b. So using these two values, we can rewrite it as a division problem. So one thing that's important to remember is that the base of the log goes in the base of the fraction. So let's look at two examples. And I also want to talk about how to enter this in your calculator. So first we have log base 7 of 3. So we're going to rewrite this as the log of 3 divided by the log of 7. Now, when you go to put this in your calculator, it's very important that you pay attention to parentheses. So when you hit log, your calculator will automatically put in a parenthesis for you. So then you'll enter the 3 and you have to close this parenthesis. If you forget to do that, you will get the wrong answer. And then you can do divided by, and then on the bottom we'll have log. It'll put in the parenthesis for you, and then 7 and close the parenthesis. So if you do this correctly, we'll take this to 4 decimal places. You should get 0.5646. So let's look at the next one, log base 5 of 10. So we would start by rewriting this as the log of 10 divided by the log of 5. So when we go to put this in the calculator, it's going to look like this, log parentheses around the 10 divided by log and then parentheses around the 5. And if you do that correctly to 4 decimal places, you should get 1.4307. We're going to look at a few different strategies for solving logs and exponentials, and our first one is to rewrite exponentials so that they have the same base. So for instance, let's say we had 3 to the x is equal to 27. Well, I can rewrite 27 as 3 to the 3rd power because 27 is a power of 3. So if I were to rewrite that, I would have 3 to the x equals 3 to the 3rd. Now that they have exactly the same base, I see that these exponents would have to be the same, so x would have to be equal to 3, and that would be my answer. So let's look at another one. Let's look at 32 to the x plus 2 power is equal to 2 to the 7x plus 2 power. So I can rewrite 32 as a power of 2. So that would be 2 to the 5th. And then I still have that x plus 2 exponent there. So I need to make sure to put it in parentheses so that I distribute. And that's going to be equal to 2 to the 7x plus 2 power. Now that my bases are the same, I know that these exponents have to be the same. So 5 times x plus 2 has to be equal to 7x plus 2. I'm going to distribute, so 5x plus 10 is equal to 7x plus 2. And then we'll start solving. I'm going to move the 5x over. So 10 is equal to 2x plus 2. I'll move that 2 over. 8 is equal to 2x. So if we divide both sides, we get x is equal to 4. Let's look at one more like that. Let's look at 625 to the x minus 9 power is equal to 125 to the x minus 12 power. So both 625 and 125 can be written as 5 to some power. So 625 is 5 to the 4th, and 125 is 5 to the 3rd. And then I still have those exponents from before, so the x minus 9, put it in parentheses, and the x minus 12. Put that in parentheses as well. So now, again, I have the bases the same, which means these exponents would have to be equal to each other. So 4 times x minus 9 has to be equal to 3 times x minus 12. We'll start by distributing. 4x minus 36 is equal to 3x minus 36. I'm going to move the 3x over, so x minus 36 is equal to negative 36. Move that 36 over and we get x is equal to 0, which again is a perfectly fine answer. X can be 0. Our second strategy is to rewrite exponentials as logs and use log properties. So let's start with 7 to the x is equal to 12. This is an exponential, so we're going to rewrite it as a log. So log base 7 of 12 is equal to x. So all I have to do to find x is figure out this log base 7 of 12, which I can use change of base on. So log of 12 divided by log of 7 is equal to 1.2770 if we round to 4 decimal places. Let's look at a similar one that is slightly different. So let's say this time we were given 8 to the x squared power is equal to 11. So again, we can rewrite this as a log. So log base 8 of 11 is equal to x squared. And then we can use change of base to figure out log base 8 of 11. So that would be log of 11 divided by log of 8. And then the only difference between this one and the last one is we have an x squared, so we know that we need to take the square root of this answer when we get it. So remember, quadratics have 2 answers, plus or minus. This ends up being 1.0738. If we're given a problem that already has a log in it, then we want to go ahead and turn it into an exponential. So let's say we were given log of x to the 3rd is equal to 3. So remember, if we're not given a base, we know it's 10, so we're going to rewrite this as an exponential. 10 to the 3rd is equal to x to the 3rd. Well, in order for those two to be equal, these bases would have to be the same, so x would have to be equal to 10. Let's look at one that has natural log. So natural log of x is equal to 3. So remember, our base here is e, so we will rewrite this as an exponential. E to the 3rd is equal to x. And then all we have to do is calculate e to the third on our calculators, and we get x is equal to 20.0855 if we round it to 4 decimal places. Okay, now we're going to look at some mixed examples and talk about how we would approach solving them. So first one, we're going to look at e to the negative t is equal to 0.25. So this is an exponential. I'm going to rewrite it as a log. And in this case, I have to use natural log. So natural log, you can put base e if you want, but you don't have to, of 0.25 is equal to negative t. So now what I can do is figure out the natural log of 0.25 using my calculator. So I get negative 1.3863 is equal to negative t. And then all I have to do is divide both sides by negative 1. And we get t is equal to 1.3863. Okay, let's look at another one. Let's look at 52 is equal to 5 times 1.03 to the t power. Now, remember, like we've talked about with so many other functions, before I can turn this into a log, because it's an exponential, I need to isolate the exponential part, which means I need to start by dividing by 5. So that will give me 10.4 is equal to 1.03 to the t power. Now that I have the exponential part alone, I can rewrite it as a log. So log base 1.03 of 10.4 is equal to t. And then I can just use change of base. So t is equal to the log of 10.4 divided by the log of 1.03. And then I calculate that to 4 decimal places. And I get 79.2253. And that's what t is equal to in this one. Let's look at another one. Let's look at 5 to the x plus 1 is equal to 3. So again, this is an exponential. I'm going to rewrite it as a log. So log base 5 of 3 is equal to x plus 1. So now I can figure out log base 5 of 3 using change of base. So log of 3 divided by log of 5 is equal to x plus 1. So when I compute that to 4 decimal places, I get 0.6826 is equal to x plus 1, but now I need to solve for x, so I'm just going to subtract 1 from both sides, and that gives me x is equal to negative 0.3174.